Okay guys, good morning. Let us have to do some problems. So this problem is from a gravitation chapter. So let us draw the diagram and then we'll discuss what the problem is asking all about. We'll discuss also what this problem says. So till you draw the diagram, you just try to understand the figures. Then we'll read the question. Okay, let me read the question first. This says a satellite of mass ms orbiting the circuit in a circular orbit of rs. So there is a satellite S, and this satellite is moving in a circular orbit around the earth. So this is the earth. The radius of earth is given, that is re, and rs is the radius of satellite, basically radius of orbit of satellite. So you have been given rs, you have been given re, that is the radius of earth. Mass of earth is also given to you. Mass of satellite is also given to you. So ms is the mass of satellite. You can write m is the mass of earth, and r is the radius of earth, and rs is the circular orbit of planet. So these are the things that is given to you. Now the question says, let me read the next line. It starts losing its energy slowly at a constant rate c due to the collision with the dust particle. Now this satellite is moving. Let us say there are so many dust in the environment. Now if this satellite moves, this dust apply a force on this satellite, and that's why question says this satellite start losing energy, because if there is a dust particle collision are there, so there is a chance of loss of energy. So this is saying this starts losing energy, and energy loss rate is given to you. So it loses its energy with a constant rate c. So rate of energy loss is given, that is c. I have put a minus sign here because you see, as time goes, energy will be decreasing. So dE is positive, dE is negative, but dt is positive. If c is a positive number, then I have to multiply by minus sign. Why I have to multiply by minus sign? Because as time increases, dt is positive, but as time increases, energy decreases. Energy of this satellite decreases with time. So dE is negative, but dt is positive, so I have to put a negative sign here. Are you getting or not? Okay. Now the question is asking, what is the time required after which the satellite will fall on the earth? And this time is given to you. So basically you have to prove that the time required when satellite fall on earth in a time is this. So you have to prove this is the time required to fall the satellite on the earth. How will you do that? What will happen? You see, what is the motion of satellite? This will move. So if energy is lost, if you remember the energy, total energy of satellite, use that expression and you can find this will move in a spiral path. So you prove yourself this can move in a spiral path. Let me give you one other hint, that you first find out the total energy of satellite, differentiate that energy, and then you have to do some integration. I will take 1.5 minute time so that you can do this one, and then we'll go for the next problem. So let me wait for 1 minute. You do your own. Anybody? Not it. Okay, so let us check out the solution. So you see, if this satellite is moving, so total energy of satellite E, that is the total energy, is sum of kinetic energy plus potential energy. Everybody knows if it is moving in a circular orbit, the kinetic energy will be half mv square and potential energy is minus gmm by r. Now if you remember, this is the mass of satellite, that is mass m. So mass of satellite is ms b square. Here I have mass of satellite and mass of earth. So this is mass of satellite and this is mass of earth. So g ms me by r. Now if you remember, orbital velocity is under root g me by r. So if anything is moving around the circular orbit, orbital velocity becomes under root gm by r, where m is the mass of earth. So orbital velocity is gm by r. Now if I plug the value of velocity, I will get the total energy expression something like this. So total energy, this is the, if I plug the value of V, so this becomes ms gme by r, because r square, so the square will becomes r. So this is the kinetic energy. And potential energy, this is already we have written. If you see, this term is basically double of this term with a minus sign. This is always true. If you have a system, if you have a force system that varies with 1 by r square, you will always find and potential energy is twice the kinetic energy with a double sign. Are you getting or not? Kinetic energy will be plus and potential energy will be minus, because kinetic energy can't be negative. So this is potential energy is double of kinetic energy, so the total energy will be negative. This total negative energy shows system is bound. That is, the system is bound means that the two particles are basically attracting to each other, so motion will remain forever. That is the bound system. Now the total energy will come out to be this. So if you subtract this one, this is the total energy. Let me wait for 1 minute so that you can copy this one. Now things is easy. What we can do is, now if we differentiate this equation dE by dt, let me write first here. So if I differentiate dE by dt, this is constant, and 1 by r differentiation minus 1 by r square, there is a minus sign over. And now I have to differentiate r also, so dr by dt. So another integration is dr by dt. Now see, this is given, so du dy is given to you, there is minus c, that's the rate of loss of energy is minus c. Now if I put this as minus c, and if I write this term here, so minus minus cancels out, so I can write gms me by 2r square, let me write, and divided by into dr by dt. Are you getting? Now I can write here, so if I take this dr by dt that side, so I can write minus 2c, so this is c minus c, and 2 comes out, so minus 2c divided by gms me is equals to dr by r square. Are you getting or not? So minus 2c divided by gms me into dt. So this is minus 2c divided by gms me into dt is equals to dr by r square. Now you know at time t equals to 0, it was at radius rs, circular orbit radius rs. At time t is equals to t, now it has fallen onto the earth, so this is on the radius re, that is the radius of earth. Now if you integrate this one, you will get the answer. You integrate yourself, you have to do some work. So if you will integrate this one, you will get the desired result. So this is all about this problem. If you remember, okay, let me give you 1 minute time. Are you getting this result? If you are integrating, are you getting this result? That is 2 gms me divided by 2c under a square bracket 1 by r minus 1 by rs. You will get the minus sign also correctly here. Now see, if you remember the Rutherford experiment, this is related to the experiment of Rutherford. You see, now if you remember the Rutherford experiment, it says electron is moving. If electron is moving around the positive charge nucleus, and this says this radiates energy. If this radiates energy, this means this is the time, so this is the required time, so this will be a finite time. In that case I will put the mass of electron, mass of nucleus, resistive force, if the energy loss is C basically, so I can find time after which it will fall into the nucleus. Are you getting or not? So this is the required time after which, so same idea, after which this electron will fall into the nucleus. So the electron moving in a circular orbit is not a stable way to have an atom. So this, what will happen? So this will take a spiral path and finally it will fall. Why this will take a spiral path? You see, as soon as this energy decreases, and energy is directly proportional to radius. So if energy decreases, I have to decrease the radius. Are you getting or not? If energy, because this is the minus sign, energy decreases, I have to decrease the radius. So less energy. If energy is decreasing, so it has less energy, so this means I have to decrease the R because of the minus sign. So I have to decrease the R, and that is possible. That's why, so if it loses a small amount of energy, it will take this radius. If it loses for more amount of energy, this will take this radius. So radius will slowly go shorten, and finally it will fall onto the nucleus. Are you getting or not? So this is the idea of Rutherford. The Rutherford model is not valid. So this is the basically objection to the Rutherford model. We'll discuss the next problem.